For millennia, humanity has stood beneath the star-studded night sky, wondering about the nature of the twinkling lights scattered across the vast darkness. Those distant points of light, once thought to be mere stars within our own galaxy, slowly revealed themselves to be much more. Galaxies, colossal assemblies of billions upon billions of stars, swirling clouds of gas and dust, and the enigmatic dark matter that binds them all together. Galaxies are not isolated islands, but fundamental units in the cosmic ocean, each a miniature universe unto itself, containing secrets about the origin, evolution, and ultimate fate of the cosmos. However, much of this vast universe remained veiled, just beyond the reach of human eyes, until a revolutionary instrument was launched beyond Earth's atmosphere, the Hubble Space Telescope. From its vantage point in orbit, Hubble opened a window through the murky veil of our atmosphere, providing humanity with crystal-clear visions of galaxies both near and incredibly distant. Through Hubble's lens, we began to read the grand narrative of the cosmos, stories written in starlight and cosmic dust that had never been told before. When Hubble was first launched in 1990, it represented the pinnacle of human engineering and ambition, an observatory capable of seeing the universe in unprecedented detail. Positioned above the turbulence and light pollution of Earth's atmosphere, Hubble was free to capture the faintest glimmers from the edges of the observable universe. Early images surprised scientists and the public alike. Galaxies that had appeared as blurry smudges from Earth suddenly revealed stunning structures, spiral arms filled with young stars, chaotic bursts of star formation, and dark lanes of dust weaving intricate patterns. This newfound clarity reshaped our understanding of the cosmos and ignited a renaissance in astrophysics. For decades, Hubble has tirelessly scanned the skies, unveiling galaxies of every shape, size, and age. It has become a time machine, peering billions of years into the past, allowing us to witness the birth and evolution of galaxies across cosmic epochs. Perhaps no image captured by Hubble has been more transformative than the Hubble Deep Field. By focusing on a tiny, seemingly empty patch of sky for nearly 11 days, Hubble uncovered a staggering array of faint galaxies, thousands of them, spanning a vast range of distances and cosmic time. Each speck of light in the deep field represents a galaxy, some formed just a few 100 million years after the Big Bang, offering an unprecedented glimpse into the universe's infancy. This tiny snapshot expanded our view, revealing a universe teeming with galaxies where once we thought there might be only darkness. The deep field also revealed the incredible diversity of galactic forms in the early universe, some compact and primitive, others larger and more evolved. This discovery provided critical evidence supporting theories of hierarchical galaxy formation, where small proto-galaxies merged over time to build the massive galaxies we see today. Thanks to Hubble's powerful eyes, astronomers have traced the complex life cycles of galaxies. Spiral galaxies, with their graceful, curving arms, are often seen as cosmic cradles, nurturing waves of star formation that light up their disks with brilliant blue hues. Our own Milky Way is one such galaxy, a sprawling system where stars are born, live, and die in cycles of cosmic renewal. Elliptical galaxies, in contrast, appear more serene, rounded, smooth, and composed primarily of older stars. Hubble showed that many of these ellipticals likely formed from the collisions and mergers of spiral galaxies, violent events that transformed their shape and star formation patterns. Irregular galaxies, chaotic and asymmetrical, often hold clues about the more tumultuous periods in galactic history, where interactions with neighbors or bursts of star formation disrupt the regular order. By cataloging galaxies across vast stretches of space and time, Hubble has helped decode the evolutionary pathways galaxies follow, revealing a cosmos in constant motion and transformation. Beneath the dazzling visible light of galaxies lies a profound mystery: dark matter. This invisible substance outweighs ordinary matter and exerts gravitational forces that shape galaxies and the large-scale structure of the universe. Hubble's high-resolution imaging, combined with observations of gravitational lensing, where the gravity of massive galaxies bends the light of objects behind them, has provided some of the clearest evidence of dark matter's pervasive influence. These observations revealed that galaxies are cocooned in massive halos of dark matter, unseen but essential for holding galaxies together and influencing how they rotate and cluster. Hubble's role in exposing the invisible architecture of the cosmos continues to be vital in unraveling the true nature of dark matter, a puzzle at the forefront of modern astrophysics. Galaxies are not static islands, but dynamic participants in a cosmic ballet. Hubble has captured breathtaking images of galactic collisions, dramatic encounters where gravity tears apart stars, gas, and dust, triggering brilliant bursts of star formation. These collisions are not mere cataclysms, but fundamental to galactic evolution, driving the growth of galaxies and often igniting supermassive black holes at their centers. Hubble's images show tidal tails stretching like cosmic rivers, star clusters born from gravitational chaos, and the merging cores of galaxies fusing into singular massive systems. By studying these interactions, we glimpse the future of our own Milky Way, which will collide with the neighboring Andromeda Galaxy in about 4 billion years, a monumental event that will reshape our cosmic neighborhood. At the heart of nearly every galaxy lies a monstrous secret, a supermassive black hole, millions to billions of times the mass of the Sun, anchoring the galaxy with immense gravity. Hubble's sharp vision has been crucial in detecting and measuring these black holes, observing the rapid motion of stars and gas swirling around galactic cores. These black holes influence their host galaxies profoundly, regulating star formation through powerful jets and radiation, shaping the evolution of entire galaxies over cosmic time. Hubble's observations have unveiled the intricate dance between galaxies and their central black holes, a relationship that remains one of the great mysteries of cosmic evolution. The discoveries made by the Hubble Space Telescope extend far beyond academic knowledge. They reshape our very understanding of the universe and humanity's place within it. Hubble's revelations have helped answer fundamental questions about where galaxies come from, how they grow, and how the universe itself has evolved over billions of years. Its images inspire awe and wonder, sparking the imagination of scientists, educators, and the public alike, connecting us to the cosmos in profound ways. Through Hubble, we have learned that the universe is a dynamic, evolving tapestry, complex, beautiful, and vast beyond comprehension, inviting us to continue exploring, questioning, and dreaming. Even decades after its launch, Hubble remains at the forefront of astronomical discovery, continuously pushing the boundaries of human knowledge. As new instruments like the James Webb Space Telescope prepare to explore the universe in infrared light, they stand on the foundation built by Hubble's unparalleled legacy.